We've all heard it, right? That piercing, heart-stopping sound of a fire alarm. But have you ever actually stopped to think about what makes it work? I mean, really work, every single time. What's the hidden system that ensures you can trust it with your life?
Well, let's really get into that, because the answer isn't just about some plastic device stuck on the ceiling. It's about a massive, incredibly detailed rulebook that dictates every single moment of that alarm's life, from the day it's designed to its weekly checkup.
So here's the game plan for this explainer. We're going to start with the unseen safety code itself. Then we'll look at the blueprint for a fire alarm, see how it picks the right senses, find out what it takes to keep the whole system ready to go, and finally get into why false alarms are a much bigger deal than you think. Okay, let's start at the very beginning, the foundation. The reason any electrical fire alarm system in Singapore is reliable comes down to one critical document, Singapore Standard 645, or SS645 for short.
Think of this as the ultimate code of practice. And let me be clear, this isn't a friendly suggestion, it's the rulebook. Its entire reason for being is to make sure every single alarm system is designed, built, and maintained to the exact same high standard. It's all about creating predictable, life-saving reliability.
So how does a document full of rules actually create a physical system? Let's jump into the design phase and see how SS645 builds a fire alarm from the ground up, starting with the most important parts.
At the absolute heart of everything is the main alarm panel, or the map. You really have to think of it as the brain of the whole operation. It's not just a box that makes noise, it's a command center that's constantly gathering information, making critical decisions, and talking to the outside world.
Now, to make that information actually useful, the building gets divided up into what are called alarm zones. This is so important. Instead of an alarm just screaming that there's a fire somewhere in a giant building, the zone system tells firefighters exactly which area to rush to. It saves precious, precious time.
And the code is incredibly specific about this. Get this, one alarm zone generally cannot be bigger than 2,000 square meters. This rule literally ensures that the search area for first responders is always a manageable size. It's a simple number, but it's a core principle of rapid response that's designed right into the building's layout.
The code even gets down into the nitty-gritty of the box the brain lives in. It has to be red, so you can spot it immediately. It needs to be tough, and it has to be lockable to stop anyone from messing with it. And you know that little break glass box for the key right next to it? Yeah, that's a requirement too, making sure the right people can get in fast. It just shows you the insane level of detail in SS645.
Okay, so you have a brain. But a brain is pretty useless without its senses, right? The code provides a super detailed guide for choosing the perfect type of detector for every possible environment, making sure the system can actually feel a fire as early as possible.
The two main players are heat and smoke detectors, and there's a really important trade-off here. Heat detectors are tough. They're great for places like kitchens or workshops where dust and fumes would cause false alarms. But when it comes to protecting human life, smoke detectors are the absolute champions. Why? Because they react way faster to those sneaky, smoldering fires that can choke an escape route with toxic smoke.
And believe me, it gets even more specific. Just within heat detectors, the code breaks it down into different classes. For instance, a Type B detector is perfect for a kitchen. Temperatures can jump around a lot when you're cooking, so it's designed to only go off at a very high fixed temperature. But a Type A detector for a normal office, it's looking for a rapid rise in temperature, which is a much better sign of a real fire in that environment. This kind of precision is what helps minimize those annoying false alarms.
The code also gets into the geometry of placement with military-like precision. For a standard flat ceiling, the distance from any single point to the nearest smoke detector can't be more than 7 meters.
And this isn't just some random number they came up with. This simple rule creates a kind of overlapping web of protection. It means that no matter where a fire might start, it can't get very big before its smoke is going to drift into a detector's path. It's basically a geometric guarantee against dangerous blind spots.
But look, a perfect design doesn't mean a thing if the system fails when you need it. And that's exactly why the code demands a really tough schedule of testing and maintenance. It's all about making sure the system is always, always ready.
This isn't a check it when you feel like it kind of thing. The code enforces a relentless cycle of checks. It starts simple, a visual lookover every single day. Then every week, you test the link to the monitoring station. Every month, you blast the sounders and even simulate a power outage. And finally, the big one, every single year, you have to physically test at least 20% of all detectors and call points.
Now, When you do the math on that 20% rule, it means that over a 5-year period, every single component of that system, every button you could press, every detector on the ceiling, has been individually, physically tested to prove it works. It's a long-term strategy that guarantees the whole system is solid.
Okay, finally, let's talk about something we've all experienced, the false alarm. It might just seem like an irritation, but SS645 treats false alarms as a serious threat, a threat to the entire system's credibility. The code is smart. It actually categorizes them so we can understand them better. You've got unwanted alarms, that's your burnt toast. You have equipment false alarms, where a part just fails. Then there are malicious ones, and even false alarms with good intent, where someone genuinely thought they saw smoke, but it was just steam.
And this all leads to a fundamental principle, a golden rule, written right into the code that warns us all against getting complacent. The biggest danger of too many false alarms is that people just stop taking them seriously. This rule is a powerful reminder. You have to assume every alarm is real, until you know for a fact that it's not.
To fight against this complacency, the code actually puts the responsibility on the building owners to manage their environment. We're talking about simple stuff, like not doing dusty construction work right underneath a smoke detector without taking precautions first. It's all part of keeping the system reliable and making sure people trust it.
So from the color of a box to a 5-year testing cycle, SS645 is this invisible, exhaustive set of rules working 24/7 in the background. It's what turns a simple piece of plastic on the ceiling into a system you can actually trust with your life. So the question is, has this changed how you'll look at the next one you see?